our universe might not have a start. For quite a long time, we put stock in the hypothesis of the Big Bang, but now, genuine observations of the early universe show us something totally different. Behind the Pandora Universe Group, the James Webb Space Telescope has found a mysterious structure so old and so enormous that it could never have existed in a young universe. This gives us additional proof that our hypotheses about the Big Bang and the age of the universe are off. There may never have been a beginning. The idea that something could have no start and no end brings on some issues for many of us. We are accustomed to thinking in spatial dimensions where things and cycles have a start and an end, or limits. Scientists also struggle with infinity because it presents unsolvable mathematical problems. Scientists can only work out quantities of length, width, and height within a defined space. If our universe is really unlimited, then it has no length, no width, and negative length, in fact. However, most of our current theories about the beginning and development of the universe rely on measurements that assume a space that is closed in some way. Since the James Webb Space Telescope has provided us with more and more evidence that the past explanation of the universe's evolution is incorrect, other theories are becoming increasingly plausible. Toward the dawn of mankind, astronomers gave the idea that galaxies should appear as though they are already billions of years old. These early galaxies should have given signs of a beginning stage of development. Scientists also expected to see, at last, the very first brilliant stars of the universe through James Webb. But here, too, there has been no sign so far. All we see are structures that look so old that the Big Bang could never have occurred 13.8 billion years ago. What is behind the Pandora Group? In February 2023, NASA released another deep image taken by the James Webb Space Telescope. Here, we see the Pandora Group, also known as Able 2744, with the early consolidation of three massive galaxy clusters apparent in the foreground. This incredible discovery was made possible by Webb's near-infrared camera. Webb uncovered the individual segments of the group for as long as 6 hours and then perfectly assembled the new deep image from 5 individual pictures. The picture shows around 50,000 light sources, the oldest of which are said to reveal further secrets of the early universe. There is more to this picture than just another brilliant concept of telescope innovation. The massive group acts as a unique gravitational lens and amplifies all objects behind it. Because of the shape of space-time, the ultra-deep close-up and near-infrared observations before the APO, epoch of reionization, program are responsible for this picture. Scientists investigated each hint of light in the image and noticed something that once again calls our standard models of cosmology into question. Behind the group, a structure became visible that is so huge and gigantic that it's inconsistent with our previous illustrative models of the early universe. Iron has set itself the goal of capturing the first light signal from the epoch of reionization. At that time, the universe is said to have been mostly dark. Anyway, the image again shows that some of the points of light are probably galaxies that are over 13 billion years old, which again implies that they are far too old for our current explanations. This picture adds to the mystery of astronomy with the mysterious construction. Preliminary estimates showed a redshift value of Z equals 7.9, meaning the object was already present around 650 million years after the Big Bang. The structure could be a protogalaxy group, but how could massive galaxy groups have already formed 650 million years after the Big Bang, if at that time there were supposedly only the first stars or protogalaxies? Once again, the old theories are being tested, and this discovery increases the likelihood of a much older or even infinite universe. The photometric NIRCam data from the image has now been made available to many global research groups, and astronomers around the world are now working together to uncover the truth. What if the Big Bang never happened? It's astonishing. We are currently facing more possibilities in cosmology than we have for quite some time. Before the telescope was launched, scientists were actually expecting the long-anticipated confirmation of their theories, but now completely new scientific dimensions are opening up, and we will experience changes. What could this mean? Now, we may soon be able to look much further back in time. And if we still can't find any signs of an early universe 14 billion light-years away, we will at least know for sure that our universe is much older than previously expected. This would not yet be evidence of infinity, but this possibility would become more likely. Again, we should investigate what supports this. The uniform distribution of the cosmic microwave background radiation across the whole sky shows that the universe is homogeneous and isotropic on a large scale. Both can be interpreted as signs of an endlessly expanding universe. The Hubble Space Telescope, moreover, showed us that the universe has a flat geometry. Some researchers also interpreted this as a potential sign that our universe is infinitely stretched out, suggesting there may be another reality we should not disregard when considering the topic of the infinity of our universe. Nobody has yet found an end to the known universe. We study more than 90 billion light-years, but there is no proof of an end. Ideas about the edges of the universe have so far been pure intellectual exercises, not proven facts. James Webb's revelations now show that there is no start on the timeline either. Demonstrating an infinite universe will be difficult because even the best telescopes can never show infinity. Regardless of whether we one day travel through space in spaceships, we could never know for sure if it has an end until we find it. What might a limitless universe mean? It sounds captivating to live in a universe that continues endlessly, has no starting point and no closure, and has forever been there. Just our science experiences issues with this thought. There are the previously mentioned issues of portraying such a universe experimentally and precisely. Boundlessness would imply that we are probably not going to prevail with regard to doing simply that. We can explore halfway regions and make estimated predictions about which forces are working there and where they come from, but the totality of the boundless universe would probably escape numerical and scientific perception. Who says that we need to measure and logically make sense of every side of the grand universe? We need to ask ourselves why we are so carefully looking for this data and understanding of the universe. It's because we are searching for answers about our own beginnings. Where did everything come from? Who made it and what is it doing here? Inherent science tries to make sense of these inquiries with equations and computations, but it is now reaching its limits. However, receptive scientists also see the new discoveries as an opportunity to learn more about the universe in a totally new way. The discoveries might enable us to reach new levels with our exploration. So far, we need to admit that, despite numerous speculations and telescopes like James Webb, we still have barely any familiarity with the universe. The vastness of the universe could also imply that we are in a sort of time-space loop or in a well-made holographic projection. This would mean that we need to develop our awareness and minds to figure out the true essence of the universe. Might we be able to get to the truth with a quantum computer? Now we come to an exciting part in the investigation of the universe that could truly be a transformation: quantum computers. They may soon be so powerful and intelligent that they will give us answers to all the questions without us searching for long. These intriguing machines use the principles of quantum mechanics to process gigantic amounts of data or perform complex computations. Quantum computers use qubits, which, unlike the bits of traditional computers, can not only accept the states 0 or 1 but also superposition states of these values. As you might know, quantum mechanics consolidates all potential outcomes and only interprets a certain structure when they are measured. This behavior shows that quanta theoretically contain all the possibilities, not just the information of this universe. We just need to figure out how to decipher the code of quantum language and program the technology so that it provides us with answers that go beyond observational possibilities and classical numerical estimations. Let's take the issue of the contradiction between Einsteinian physics and quantum mechanics. So far, only string theory exists that can close the gap between the two, but we can't prove string theory because it includes undetectable aspects. There are now endless variations of string theory, and not a single one of them fits perfectly. A quantum computer could accommodate this information and show us our errors in an extraordinary way. It could replace existing gaps and confusions with lucid computations. We could even combine quantum computers with artificial intelligence, and then we would likely have access to nearly perpetual information. Telescopes would then be another fun way for us to observe the beauty of the universe, but we would no longer need to piece together carefully what we see into an inestimable puzzle. Scientists anticipate that even the simplest versions of quantum computers will be able to show us, potentially, whether dark matter really exists. So far, we have used the assumption of dark matter to explain irregularities in the development of galaxies, but its presence has never been definitively proven. The quantum computer could give us many explanations for the anomalies that we have so far explained with dark matter and could also show us whether the concept of dark matter is real or a mistake. The first models of these computers are already in use at the moment. The developers are still having issues with the sensitivity of these advanced machines. Quantum computers are very delicate to vibrations and are only operated in specially insulated rooms. Cooling presents a further challenge. Fundamentally, however, these processes are just an advancement of the massive computers that existed during the 1960s and 70s. Today, we have little workstations and cell phones, things that people who worked with the original beast computers would never have dreamed of in those days. It just took years and years for computer technology to progress to the point where it could be found in nearly every household.